Certified Fiber Optics Final Exam, Fiber Optics Final Test, Fiber Installation and Testing, Optical Fiber Certification, Fiber Troubleshooting, Verified Answers, Fiber Optics Technician Exam. Question 1. What is the primary function of the cladding in a fiber optic cable? To provide tensile strength to the cable. To trap light in the core using total internal reflection. To protect the glass from moisture. To conduct electrical power for repeaters. The cladding has a lower index of refraction than the core, which causes light rays to bend back into the core, maintaining total internal reflection. Question 2. Which physical characteristic distinguishes single-mode fiber from multi-mode fiber? A larger overall cable diameter, a much smaller core diameter, a highly flexible outer jacket, a different cladding diameter. Single-mode fiber has a tiny core, usually around 9 microns, which allows only one mode of light to propagate, eliminating modal dispersion. Question 3. What determines the index of refraction in an optical fiber material? The speed of light in a vacuum divided by the speed of light in the core material. The diameter of the core divided by the diameter of the cladding. The wavelength of the light used. The pulling tension applied during installation. The index of refraction is a ratio showing how much light slows down when it travels through a denser medium like glass compared to a vacuum. Question 4. What is the standard outer diameter of the cladding for both single-mode and multi-mode telecommunications fiber? 50 microns, 62.5 microns, 125 microns, 900 microns. Regardless of whether the core is 950 or 62.5 microns, the standard cladding diameter for telecom glass fiber is always 125 microns. Question 5. Which of the following wavelengths is primarily associated with multi-mode fiber systems? 1310 nanometers, 1550 nanometers, 850 nanometers, 1625 nanometers. Multi-mode systems typically operate at 850 nanometers and 1300 nanometers, while single-mode systems operate at 1310 nanometers, 1550 nanometers and higher. Question 6. What does the acronym OTDR stand for? Optical Transmission Data Router, Optical Time Domain Reflectometer, Outside Telecom Distribution Ring, Optical Testing and Diagnostic Reader. An optical time domain reflectometer is a specialized testing instrument used to measure fiber length, detect faults, and measure splice loss by analyzing backscattered light. Question 7. What is the primary danger when working directly with bare optical fibers? High voltage electrical shocks, burns from the laser light, small blast shards piercing the skin or eyes, toxic chemical exposure from the glass. Bare fiber shards are extremely sharp and nearly invisible. They can easily penetrate the skin or eyes, causing serious injury and infection. Question 8. What causes Rayleigh scattering in an optical fiber? Bending the fiber too tightly, variations in the glass density and composition from the manufacturing process, water entering the cable jacket, a poorly polished connector end face. Rayleigh scattering accounts for the majority of inherent attenuation in a fiber. It is caused by microscopic density variations in the glass that scatter the light. Question 9. Which type of light source is primarily used for long-distance single-mode fiber networks? Light-emitting diodes, vertical cavity surface-emitting lasers, laser diodes, halogen bulbs. Laser diodes output high power and a very narrow spectral width, making them ideal for long-distance and high-speed single-mode transmissions. Question 10. What color is the standard outer jacket for single-mode indoor patch cords? Aqua, orange, yellow, green. Industry standards dictate that single-mode indoor patch cords should have a yellow jacket to prevent mix UPS with multi-mode cables. Question 11. What color is the standard outer jacket for OM3 and OM4 multimode indoor patch cords? Orange, aqua, yellow, blue. Laser-optimized 50-micron multi-mode fibers like OM3 and OM4 use an aqua jacket, while older OM1 and OM2 fibers typically use an orange jacket. Question 12. What is the core diameter of legacy OM1 multi-mode fiber? 9 microns, 50 microns, 62.5 microns, 100 microns. OM1 is the older legacy multimode standard featuring a 62.5 micron core. Modern multimode fibers use a 50 micron core. Question 13. What happens if a fiber optic cable is bent beyond its specified minimum bend radius? The fiber will stretch and increase bandwidth. Macro bending loss occurs and the glass may eventually break. The index of refraction will change. The cladding will separate from the core. Bending a fiber too tightly allows light to escape the core, causing macro bending loss and places severe physical stress on the glass, leading to failure. Question 14. What does an angled physical contact APC connector reduce? Insertion loss, optical return loss and backreflection, cable strain, modal dispersion. APC connectors have an 8-degree angle polished into the end face, which forces reflected light into the cladding rather than allowing it to travel back to the source. Question 15. What color is the connector body or boot for an APC single-mode connector? Blue, beige, green, red. Green is the standard color for APC connectors, indicating they have an angled polish and should never be mated with a flat or UPC blue connector. Question 16. What is the standard maximum pulling tension for outside plant fiber optic cable during installation? 50 pounds, 150 pounds, 300 pounds, 600 pounds. Standard loose tube outside plant cables are designed to withstand up to 600 pounds of pulling tension using strong aramid yarn or fiberglass rods. Question 17. What type of fiber cable construction is most commonly used for outside plant installations? Tight buffer, loose tube, ribbon patch cord, simplex zip cord. Loose tube cables isolate the delicate fibers from environmental stresses like temperature changes and physical pulling forces using gel-filled or dry water blocking tubes. Question 18. What type of fiber cable construction is typically used for indoor patch panels and short building runs? Loose tube, aerial drop, tight buffer, armored direct burial. Tight buffer cables have a 900 micron plastic coating applied directly over the fiber, making them easier to handle and terminate in indoor environments. Question 19. What is attenuation in a fiber optic link? The increase in signal strength over distance. The reduction in optical power as light travels through the fiber. The spreading of a light pulse. The reflection of light at a connector. Attenuation is the loss of optical power measured in decibels resulting from scattering, absorption, and physical bends in the fiber. Question 20. Which unit is used to measure optical power loss in a fiber link? Volts, amperes, decibels, nanometers. Decibels are used to express the ratio of input power to output power, providing a standard measurement for attenuation or loss. Question 21. When calculating a loss budget for a network design, what components must be included? Only the length of the fiber cable, fiber attenuation, connector loss and splice loss. Only the connector loss, the power of the transmitter only. A loss budget must account for all passive losses in the link, including the fiber itself, all mated connector pairs, and all splices. Question 22. What must be done to a bare optical fiber immediately before fusion splicing? It must be coated with matching gel. It must be stripped, cleaned, and cleaved. It must be polished with fine grit film. It must be heated with a torch. The fiber must have its protective coatings stripped away, then it must be thoroughly cleaned with alcohol and precisely cleaved to ensure a perfect flat face. Question 23. What defect does a poor cleave cause during the fusion splicing process? It changes the core diameter. It alters the index of refraction. It causes high splice loss or causes the fusion splicer to reject the splice entirely. It melts the cladding. A poor cleave leaves an uneven or angled glass surface, preventing the fusion splicer from aligning and melting the fibers together properly. Question 24. What generates the intense heat required to melt two optical fibers together in a fusion splicer? A tiny gas flame, an electric arc, a high-powered laser, a chemical reaction. Fusion splicers use high-voltage electrodes to generate an electric arc that melts the silica glass, allowing the two ends to fuse together. Question 25. What is a typical acceptable loss target for a good fusion splice? 0.1 dB or less, 0.5 dB, 1.0 dB, 3.0 dB. Fusion splicing is the most accurate method of joining fibers, and a high-quality splice typically exhibits a loss of 0.1 dB or completely unmeasurable loss. Question 26. What is the purpose of index matching gel inside a mechanical splice? To glue the two fibers together permanently. To reduce Fresnel reflections by matching the index of refraction of the glass. To clean the fiber end faces. To conduct electricity. The gel fills the microscopic air gap between the two cleaved fibers, preventing severe backreflection and reducing insertion loss. Question 27. Which parameter measures the amount of light reflected back toward the source by a connector? Insertion loss, optical return loss, chromatic dispersion, numerical aperture. Optical return loss measures the ratio of the light reflected back to the source compared to the light transmitted into the connector. High return loss is desirable. Question 28. What tool is used to visually locate sharp bends, breaks, and faulty connectors in a fiber patch cord? Optical loss test set, visual fault locator, fusion splicer, microscope. A visual fault locator uses a bright visible red laser. The red light will leak out of the cable jacket at the exact point of a severe bend or break. Question 29. What does an optical loss test set OLTS consist of? A microscope and a cleaning kit, a light source and a power meter, an OTDR and a launch cable, a fusion splicer and a cleaver. An OLTS pairs a stabilized light source with an optical power meter to measure the total end-to-end insertion loss of a fiber link. Question 30. When testing a fiber link with an OLTS, what crucial step must be performed before measuring the link? Splice a new pigtail on the end. Set a reference using standard test reference cords. Turn the laser to maximum power. Measure the distance with a tape measure. Setting a zero reference with high-quality test cords subtracts the test equipment loss, ensuring you only measure the loss of the installed link. Question 31. What is the most common cause of high insertion loss and reflectance at a fiber optic mated pair? A broken laser, dirt and contamination on the connector end faces, using the wrong wavelength, a perfectly flat cleave. Even microscopic dust particles or oil from skin can block the light path or hold the physical contact apart, causing massive signal loss. Question 32. Which cleaning method is considered best practice for heavily soiled fiber optic connectors? Blowing on it with your mouth, wiping it on your shirt. Dry cleaning first, then wet to dry cleaning using specialized lint-free wipes and fiber optic solvent, scraping it with a razor blade. Proper cleaning requires specialized lint-free materials. Using a dedicated solvent followed by dry wiping ensures all residues are removed without scratching the glass. Question 33. What is a dead zone on an OTDR trace? A section of fiber that is perfectly clean. A distance where the OTDR cannot make accurate measurements due to the detector being blinded by a strong reflection. The very end of the fiber link. A zone with no attenuation. High reflections from mechanical splices or dirty connectors can saturate the OTDR receiver, causing a blind spot immediately following the event. Question 34. How can an OTDR dead zone be mitigated when trying to measure the very first connector on a fiber link? By increasing the pulse width. By using a launch cable between the OTDR and the link under test. By using a visual fault locator instead. By turning the OTDR upside down. A launch cable provides a long enough span of fiber to allow the OTDR receiver to recover from the initial laser burst before the first network connector is reached. Question 35. Why do multimode fibers experience modal dispersion? Because the core is too small. Because different light rays or modes travel different path lengths and arrive at the receiver at different times. Because the glass is impure. Because the cladding is too thick. Light rays entering at different angles bounce differently down the large core. Some travel straight while others bounce heavily, causing the pulse to spread out. Question 36. Which type of multimode fiber index profile is used specifically to minimize modal dispersion? Step index, graded index, single mode index, plastic index. A graded index core changes its refractive profile gradually from the center to the edge, speeding up the light rays that travel the longest paths so they all arrive together. Question 37. What is chromatic dispersion? The spreading of a light pulse because different wavelengths or colors of light travel at slightly different speeds through the glass. The loss of light due to a sharp bend. The physical breaking of the fiber. The separation of fibers in a loose tube cable. Even lasers emit a narrow spectrum of wavelengths. Because the index of refraction varies slightly for different colors, the pulse broadens over very long single-mode distances. Question 38. What does numerical aperture represent in fiber optics? The cost of the fiber per meter. The light gathering ability or acceptance angle of the fiber core. The exact speed of light in the core. The physical diameter of the cladding. Numerical aperture defines the maximum angle at which light can enter the core and still be successfully trapped by total internal reflection. Question 39. Which network topology uses passive optical splitters to serve multiple customers from a single central office fiber? Ring topology, passive optical network PON, mesh network, point-to-point network. PON architecture splits a single optical signal to multiple subscribers using unpaired optical splitters, making it the standard for fiber to the home deployments. Question 40. According to the TIA 598 standard color code, what is the color of the first fiber or first buffer tube? Orange, green, blue, brown. The standard color code sequence always begins with blue followed by orange, green, brown, slate, white, red, black, yellow, violet, rose and aqua. Question 41. According to the TIA 598 standard color code, what is the color of the 12th fiber? White, aqua, rose, black. Aqua is the 12th and final color in the standard 12 fiber color code sequence. Question 42. What is the purpose of Kevlar or aramid yarn inside a fiber optic cable? To conduct electricity. To make the cable flame retardant. To provide high tensile strength to protect the glass fibers during pulling operations. To absorb water. Aramid yarn is extremely strong and absorbs the physical pulling tension, so the delicate glass fibers are not stretched or broken. Question 43. What environmental hazard does water blocking gel or dry water blocking tape protect against in outside plant cables? Lightning strikes, ultraviolet degradation, moisture entering the cable freezing and expanding, which causes microbends and breaks, rodent chewing. If water enters a cable and freezes, the ice expands and crushes the fibers, creating severe microbending loss or total physical failure. Question 44. What does a bare fiber cleaver actually do to the glass? It melts the glass with a laser. It crushes the glass with pliers. It scores the glass with a hard blade and applies tension to create a perfectly flat break. It cuts the glass like scissors. A cleaver never cuts all the way through the glass. It creates a tiny micro scratch and then applies bending tension to snap the fiber perfectly along the crystal lattice. Question 45. Which type of connector features a push-pull latching mechanism and is half the size of a traditional SC connector? ST connector, FC connector, LC connector, Biconic connector. The LC connector is a small form factor connector that allows for high-density patching in data centers and equipment racks. Question 46. What type of connector is sometimes referred to as a stick-and-click connector due to its square push-pull body? SC connector, ST connector, MPO connector, SMA connector. The SC connector features a square plastic body that snaps into place with a push-pull motion. Question 47. Which connector utilizes a round metal bayonet-style coupling mechanism similar to a BNC connector? SC connector, LC connector, ST connector, MPO connector. The ST connector uses a spring-loaded twist and lot bayonet mechanism and was widely used in legacy multimode networks. Question 48. What term describes the outer protective plastic coating applied directly over the cladding during the initial glass drawing process? Primary buffer coating, outer jacket, aramid yarn, strength member. The primary buffer coating, usually 250 microns in diameter, protects the pristine glass from moisture and microscopic scratches immediately after manufacturing. Question 49. In a tight buffered cable, what is the typical overall diameter of the secondary buffer coating surrounding each individual fiber? 125 microns, 250 microns, 900 microns, 3 millimeters. Indoor tight buffered cables add a thick 900 micron plastic layer over the 250 micron primary coating, making the fibers robust enough for direct connectorization. Question 50. What is a pigtail in fiber optic terminology? A short length of fiber cable with a connector installed on one end and bare fiber on the other end. A tool used to clean connectors. A specific type of bend radius. A complete patch cord with connectors on both ends. Pigtails are fusion spliced onto incoming bare outside plant fibers inside a patch panel to provide a factory polished connector end. Question 51. What is the absolute optical power usually measured in when testing the output of an active transmitter? dB, dBm, watts, volts. dBm measures absolute power reference to 1 milliwatt. A positive dBm value is greater than 1 milliwatt while a negative dBm value is less than 1 milliwatt. Question 52. If an optical signal loses 3 dB of power, what does this mean in terms of actual light intensity? The power has doubled. The power has dropped by half. The power is completely gone. The power has increased by 10%. The decibel scale is logarithmic. A 3 dB loss represents a 50% reduction in optical power. Question 53. Why must you never look directly into the end of an active optical fiber without verifying it is dark with a power meter? The light will cause you to see spots for a few minutes. Infrared light used in telecommunications is invisible to the human eye, and high-power lasers can cause permanent retinal damage without triggering a blink reflex. The light will blind the testing equipment. The fiber will break. Because the wavelengths are outside the visible spectrum, the eye does not react to the bright light, allowing the focused laser to burn the retina silently. Question 54. What is an optical mechanical splice? A splice created by melting glass. A splice that uses physical alignment mechanisms and index matching gel to hold two cleaved fibers together temporarily or permanently. A splice made by tying a knot. A splice that requires high voltage. Mechanical splices use precision V-grooves and locking cams rather than heat, making them fast and useful for emergency restorations. Question 55. What causes microbending loss in an optical fiber? Bending the cable around a sharp corner. Microscopic deformations or lateral pressures on the fiber caused by manufacturing flaws or freezing water. A dirty connector. A poorly polished end face. Microbends are tiny localized stresses that press against the fiber core, scattering light out of the core and increasing attenuation. Question 56. Which component of an optical link is responsible for converting the received light pulses back into an electrical signal? The light source, the photodiode or receiver, The optical amplifier. The OTDR. A photodiode detects the incoming photons and translates them into electrical currents that the networking equipment can process. Question 57. What does the term fiber to the X or FTTX refer to? A specific type of fiber optic cleaver. A broad term for any broadband network architecture using optical fiber to replace all or part of the usual metal local loop. A testing standard for fiber optics. A safety protocol for handling glass. FTTX includes configurations like fiber to the home FTTH, fiber to the building FTTB, and fiber to the node FTTN. Question 58. What happens to the optical signal when it passes through a 1x2 passive optical splitter? The signal power doubles. The signal power is split roughly in half, resulting in about a 3 dB loss plus component insertion loss on each leg. The signal changes wavelength. The signal becomes single mode. A passive splitter physically divides the light energy among the output ports, meaning each port receives a fraction of the total optical power. Question 59. When reading an OTDR trace, what does a sudden spike pointing upward usually indicate? A perfectly clean fusion splice. A reflective event such as a mechanical splice or a connector pair. A break in the middle of a continuous cable. A macro bend. Connectors and mechanical splices have air gaps or glass transitions that reflect light back to the OTDR, appearing as an upward spike before the signal drops. Question 60. What is the primary reason to use an optical power meter and light source instead of just using an OTDR? An OTDR is less expensive. An OLTS provides the most accurate measurement of total end-to-end insertion loss, mimicking the actual network equipment. An OLTS can find the exact distance to a break. An OLTS does not require cleaning the connectors. While an OTDR is great for troubleshooting and finding faults, an OLTS is required for exact certification of total link loss because it measures continuous transmitted power.